Virtual threads in Java. The virtual threads are introduced in Java 17 to support high performance and lightweight concurrency. Unlike traditional Java threads, which map directly to OS level threads, virtual threads can run on a smaller number of OS level threads, making them more lightweight and easier to manage. Virtual threads are a type of cooperative multitasking and can be scheduled by the JVM without requiring any intervention from the operating system. They can run in the same thread of execution as the calling code and can yield control back to the scheduler at any point, allowing other virtual threads to run. And this can result in improved performance compared to traditional threads, especially in situations where the overhead of context switching between threads is significant. So, to use virtual threads in Java, you simply need to use the executor API and specify a fork join pool as the executor. The fork join pool will automatically manage the execution of virtual threads and allow you to write concurrent programs in a simple, efficient, and scalable manner. So, what are the steps to use virtual threads in Java? The first one is that make sure you have Java 17 or the higher version installed because they have been introduced from the Java 17. Next, you need the necessary classes. So import the necessary classes, and the classes that you use are java.util.concurrent.executor and java.util.concurrent.fork join pool classes. Then create a fork join pool instance. Create an object of the fork join pool by calling its constructor with a specified number of parallelism, which represents the number of threads that can be executing tasks concurrently. You can also use the common pool method to obtain the common pool instance. Then implement a task to be executed by a virtual thread. You can define a task or a runnable or callable and submit it to the fork join pool for execution. Submit the task to the fork join pool and then wait for the task to complete. If you need to wait for the task to complete, then you can use the get method of the return future object. So now the question comes, what could be the scenario where the virtual threads are used? So there are varieties of scenario where the virtual threads are useful, but some common one can be these. The first one is the input output bound task, IO task. Virtual threads can be used for tasks that are primarily waiting for the IO, such as reading from a file, receiving a network packet, or waiting for a database query to complete. Virtual threads can efficiently manage these tasks by yielding control to the scheduler when waiting for the IO, allowing other tasks to run in the meantime. Microservices and server side applications. Virtual threads can be used in server side applications like microservices to handle incoming requests and perform background tasks because they allow you to efficiently manage concurrency and handle high volumes of requests with a small number of OS level threads. Then, asynchronous programming is another scenario where virtual threads are useful. Virtual threads can be used to write asynchronous programs that use callbacks, futures, or streams. Virtual threads allow you to manage the concurrency of your asynchronous program without the overhead of creating and managing traditional threads. The next is concurrent data structures. Virtual threads can be used to implement concurrent data structures like queues and stacks that can be safely accessed by multiple threads. Virtual threads make it easier to implement these data structures by providing a simple, efficient, and scalable way to manage concurrency. And if you have the high performance parallel algorithms, then virtual threads can help you there as well, such as map reduce by allowing you to divide the work into smaller tasks that can be executed concurrently. Virtual threads allow you to achieve good parallel performance. So these are just a few examples or scenarios where virtual threads can be useful, The exact use cases depends upon your specific requirement and the nature and the overall requirement of your application. Virtual thread is a broad topic, and this is just a brief introduction to virtual threads in Java. More about this we'll discuss in the next part.